Hello everyone, my name is Jyoti Mishra. You would have seen few series on careers talk by me on topic related to DevOps, some interview sessions on technical program management, and I'm here again to talk about importance of knowing system architecture and design for Scrum Masters, delivery, and our technical project managers. Again, this series is not going to be a technical deep dive. The purpose of this series is to make you all aware of some key terminologies and how requirements shape up the architecture of the system which we create. Yep. So with changing time, the role of Scrum Masters, TPMs, or for that matter, delivery managers are changing. You're no longer just the facilitator, collaborator, or someone who's there to help coach, mentor the team. Rather, your role would be looked at as a strategic enabler, right? You'll be someone who could be the part of the advisory group. Hence, becomes very important that apart from your key strength, which is negotiation, persuasion, servant leadership, you are also part of architectural outcomes. And that is only possible when you know certain terms. You know how the architecture or design is created for a given requirement. So you learn about the foundational element of system architecture, how the architecture helps you come up with risk dependencies. And when we talk about a big program or project, we are always focusing on critical path, right? So if you know that for this particular project or a program, we are going to use some third party tools, or we are going to use some managed services, etc. Then you'll know, okay, on a critical path where you have to map these stakeholders, right? So knowing the architecture and design would also help you in managing your projects better. I'm not going to create anything from the scratch. There are a lot of YouTube channels dedicated specifically for system design. But the purpose for you all is not to go very deep, but at least have a breadth of knowledge about various terms which is used when we talk about system architecture. Okay? So at the end of the series, we'll also talk about some real world example. Let's briefly touch what exactly we mean by system design. Taking a layman's example, if you're building a house, right? So that the blueprint which you create for your house would be your system design. Now, when you're going and designing the architecture of your house, you would like to know, okay, how various rooms are going to fit, how we are going to move from one room to another room, or is this house scalable? Like when we have a guest, are we going to have enough space to accommodate the guest? Will it be reliable? Like if there is storm, there is anything, have we created a blueprint of the house which would support such situations? And finally, is it maintainable? Like house needs maintenance, right? You have to upgrade it, change the paint, etc. Similarly, how we do it with the software. Who's involved? Architects, component designers. So architects are the one who will be creating end-to-end design of the system. Then component designers are the one, for example, the application which we are trying to build, it has got various parts. Take example of YouTube. What do you do in YouTube? You upload a file. Um, there would be a recommendations. You'll be getting notification when the channel you've subscribed to uploads any video, right? So imagine for each of these functionality, there is a different team involved. So architect would be creating all the end-to-end design, and then for specific features, notification, recommendation, there would be a separate individual team or sprint teams, etc., who would be creating the detailed design for that particular piece. Who is going to build the design? Like once you build the design, who's going to do the development? It is developers. And now PM and SMs, they make sure that whatever is being created, whatever design has been created or whatever development is happening, it meets the business needs. And how would you get to know if it is meeting the business needs? Your requirement would be your source of truth, and your awareness of these system design concept would add in your planning. So quick review of what all, this was just a snippet of what we are going to cover. And before we go deep dive, we wanted your feedback to see, will you be interested in this series? And then only we'll go ahead and put an effort to create the series, which is going to be a 10-part episodes. So the first part, which I briefly covered, is why your SM, technical project managers or delivery should know the architecture of the system, how it is going to help in knowing the critical path, how it would help you all to know who are your stakeholders, right? If we have to create a risk register, which are the pieces where you have to come up with the mitigation or contingency, right? And then what drives system architecture? Again, requirement would be your source, but every requirement would have some business constraint, would have technical constraint, right? Maybe you want to develop a application, but the skills required to develop that application is missing in the team. So there are two ways: either you onboard people, educate them, upskill them, or you get vendors do that particular piece, right? So again, these are some of the constraints which would enable you to understand, okay, how the system architecture would be created. If we go for a vendor, then there has to be vendor procurement, right? You have to be coordinating with vendors very closely. See, so your stakeholders, your collaboration and coordination is going to depend upon the architecture of the system. We'll also understand what is a good attributes of a system architecture. Take an example of house, like what would be the good attribute? It should not break in slight storm or a rain, etc. Right? If there is more gas, we should be able to accommodate. There should be a good ventilation. It should be maintainable. It shouldn't be like once you've created, the upgrade is impossible, right? Then we'll see, okay, architecture, what all it consists of, what are its building blocks. Okay, so any application you take, for example, Zoom or YouTube, you'll have a user interface, which is your front end, right? Where users are interacting with various functionality. There would be something at the back where logics would be run, which is through your backend services. You want to deploy your applications. I'm sure you would be knowing all these things while working with various sprint teams, right? You have to test it, you have to deploy it. Also, when we talk about application, again, take an example of YouTube or take an example of Zoom. Now I'm recording this session. It would be stored somewhere, right? So how the storage works, what are various kinds of database we have. You would have heard about terms like MySQL, NoSQL, Cassandra, Postgres. So knowing the system architecture, you'll also understand why for this particular application we are using SQL, but for some other application we are going for NoSQL, etc. Right? Various patterns and styles, how data is flowing, right? So any application would have a journey, right? As a user, you're going to go through the journey. That journey would involve certain events, and for every event, there would be a flow of data. Okay? And finally, we'll learn some real world, we'll go through some websites, newsletter, where authors have talked about extensively about the real world examples. So you don't have to build anything from scratch. There are already so many uh, content available on system design. It's just that knowing. And one thing which I've also started doing is like relating those concepts of architecture with real world. For example, if you're going to restaurant, right, see how order placement work, right, how they're managing long queues, what is the purpose of receptionist, yeah, and how chef works. So, and then relate to the topics which you are studying here. And now with AI, with chat GPT, etc., things have become more simpler for understanding. So any term you come across while you're working on any project or a program, go Google it, do Chat GPT, and try to get the examples in terms of a layman. Okay, right? For example, notification service. Okay, what kind of a notification you get? You can get notification on SMS. You can get notification on email. Okay, so are we building everything from scratch, or we can use some services which are already available, right? And how those services relate to real world example. So I always say, whether you are into Scrum, whether you are into architect, whether you're into project management, testing, etc., your source of truth is always requirement. And once you know the requirement, you have the understanding what is it that we're trying to drive through this requirement. Rest of the things becomes very easy. So yes, as I said, please share. Are you excited about the series? What are, like, I mentioned some of the topics, but is there anything else you would like us to cover? So we'll be looking forward for your chats and comments. Based on that, we'll go ahead and do the recording of next sessions. Thank you and happy learning. Hello, everyone. Welcome to our session 2 on our System Architectural Foundation series for Scrum Masters, Technical Project Managers, and Scrum Masters. As we had shared in session 1, the purpose of the series is not to go into detail of these concepts, rather, share enough for you to understand where you need to focus your time on. And also, we understood that the roles are evolving. Like, you're no longer just required to facilitate, collaborate, right? As AI is coming, and as these systems are getting evolved, we are creating a large scale systems. As a delivery person or a scrum master, you start acting as a strategic enabler. Okay, so for you to act as a strategic enabler, you should know enough about the system. Now that system could be on AI, right? Or it could be our normal native applications, etc. So after this series, we'll also understand, as a technical project manager or scrum master or delivery manager, how much we should know of AI. Again, we don't have to go into detail. Even when I am learning AI or exploring these concepts, I'm not getting into the details, but I have to understand enough so that I can bridge the gap between what was the business requirement and how we are going about developing those requirements. So that's for another series. But now our focus is understanding the architectural and design of the application we've been supporting, or the teams, the sprint teams we've been supporting who are building this architecture. So before we get into the various aspects of the system architecture, from today onwards, this is what you have to do, right? One way to understand things is just to read the documentation, look at the architectural designs, component designs, or you start observing what's happening around you, right? For example, if you go to restaurant today, just see what's happening around you. What is the purpose of a receptionist? What is the purpose of queue, how they are managing large scale of orders, right? See, it's not like the moment you place an order, you get the thing which you have ordered right away. There is some waiting time. So how's that waiting time being considered? How are the workers, chefs collaborating? Okay, how are we checking that? Okay, is there enough sitting available? So just observe these things and try to think if same thing you have to build, right? In the form of a software, what are the key things you have to take care of? Similarly, you are watching this video on YouTube. So understand, okay, how are videos uploaded? The video could be very large. So how is system developed to process these large videos? What is the purpose of people asking for subscribing? How do you get those notification when you have subscribed to a certain channel, and the moment they post that video, how do you get to know about those, right, in the form of the notification? So you just have to observe. And overall, you'll see that similar pattern is followed across all the systems. So what is it that drives these decisions, right? Um, One we learned is requirement. Requirements are your source of truth, right? So as a Scrum Master, you will be working with product owners or a developer lead, etc., on ensuring that okay, we've got prioritized backlog, they are refined, and we are picking the items as per our sprint goal, etc. Now, what is there in that requirement is also we have to understand. Okay? So first thing, what drive first and most important thing which drives the system architecture is your requirement. Based on the requirement, you'll get the various component of the system. Okay. Then we'll also talk about quality attributes. Some things they won't be written in the requirement, but reading through the requirement, you'll get to know. For example, all those non-functional requirement, okay, about scalability, about load. So are they specifically written in the requirement? No. But you understand what is it that we are building. Okay. And then always that whatever is given in the requirement, not everything can be delivered as it is. There would be some constraint. Common constraint could be maybe we don't have this skill set. Okay, maybe we want to develop this application or software just for a specific operating system. When we go for that operating system, certain aspects are not feasible there, right? So it's very important to understand the system constraint as well. So one is requirement would act as your source of truth. Then what is it that you want to drive through the requirement? What are the quality attributes? Okay, is it performance? Is it scalability? And similarly, what are the constraints? Okay, you have to take care of GDPR, you have to take care of PCI DSS compliance, etc. So those would act as your constraint. Right? So how do we get to know that what is it that we are trying to achieve through the requirement, right? So there comes these your UML or sequence diagram, and this we have studied during our college time, but you understand the importance, right, when you're understanding more about system architecture or design. Not sure if people do follow these things, but wherever I've seen developers or designers following these sequence diagram, it acts as a source of documentation also. You can refer back, and in case of any incident or a defect, they really help you understand how the you like how the data is flowing, what actions would trigger what flow, right? So if you want to understand, so first level is creating these diagrams, or for us, for a delivery person, it's important to understand, okay, what is it, how the use cases are being driven. Okay, so from the use cases you'll get to know, okay, scenario, this is a example I took it from internet, which is with respect to redirecting a payment, right? So you know, okay, the customer would go onto the site. Okay, the customer would click on a buy button. Okay, now when you're clicking on a buy, and try to correlate this with Amazon also, right? When you click on the buy button, what would happen, right? If you're not logged in, you'll be asked to log in. If you're already logged in, then you'll be asked for your address, etc. You have to choose payment, right? So this makes it so clear, right? You're okay, you click on the site. We'll talk about what do we mean by web servers, etc. Right? But you can clearly see that here for the payment, what payment gateway we are using here is your PayPal, right? So that's another component in your design. Again, as a Scrum Master or a delivery person or TPM, you should understand, okay, now PayPal is also one of your stakeholders, right? So if you want to consume their API, you have to see, right? Is it public? Is it private? How are we going to communicate with PayPal? Yeah. So these are the things you have to take care in your mind while ensuring that the requirements are delivered on time, right? So simple. So through these UML diagrams, you are able to understand the scenarios in which your application would be used. Okay, then you understand the flow. Okay, you'll click the button, orders would be registered, your order would be saved. Okay, if your order is being saved, where would you save it? You would save it on in the database, right? And once the payment is processed, you would see, okay, you get a message on the screen that, okay, don't press back button or don't refresh your screen, etc. Right? So now start observing these things, and a lot of questions would come in your mind how these things are working, right? And through these actions or user flows, you'll get to know, okay, how the data is also flowing. Okay? So the first part was, how do you get to know more about the requirement? Going through these sequence diagram, understanding our use cases, our flow. Okay, what are the events which would get triggered? Now, now the questions which you would come into your mind, okay, if there are like thousands of customer at the same time clicking on this button, right? So PayPal, we are not responsible for PayPal, right? We from our side we are sending traffic to PayPal. So in case of say big billion sale or other sales, Amazon sale or Freedom sale, etc. So what is it that as a delivery person, as the owner of that application, you have to think about, okay, is PayPal ready to support that many transactions, right? If not, okay, your collaboration would start with them 1 month, 2 months before, so that they keep their systems ready to support this much of a traffic. Okay? Now we were talking about the quality attributes, which won't be explicitly mentioned, but the scenarios in which your system would be used would give you those quality attribute. Okay. So the application which we are developing, what do we need? Do we need a quick response time, or does it need to process a lot of data? Okay. Is slowness acceptable, or we want response in shortest time possible? So those would be your performance attribute, right? So if you want faster response time, then things like, okay, I need I need a response time quick. Is there any way I can frequently use data I can cache somewhere? Okay, I'm not going into these terms, but you have to think, okay, how do I achieve the performance attribute for this application? Okay, and this you can only understand when you know the requirement, and then on the back of it, okay, how do we derive high performance system? Now you can go and read about it and understand how applications which are already built, how they are taking care of response time, or for example, throughput is amount of work your system is going to do, right? Scalability. So if there would be a large traffic, how are we going to manage that? Uh, are we going to add more resources in our system, or we are going to expand the capabilities of the existing system? And when we talk about the scalability, it's not just about the scalability of the system. You have to think about team scalability. So, you know, if this we've come across a lot of time that people think that, okay, if there is time crunch, if there is a key deliverables, resources are not like human is not available, developers are not, adding a more developer, will it solve our problem or it would cause more problem? It would cause more problems, right? Because there would be more handoff, one has to review the changes, there would be so many to develop and very few to review. So those are also the things you have to take care of while talking about scalability. Similarly, availability, how is it okay if your system goes down, right? So if it's a banking system which we are trying to build, okay, is availability important factor, or security is important factor, or performance is important factor, right? So based on that, again, the various component of the system would be decided. Finally, fault tolerance. See, this is the application, it's a software. So there could be either human error, right? Or it could be a system error, or it could be your hardware error. So you have to see in such scenarios, is your system fault tolerant? Okay. So one way to understand fault would happen, right? But the important factor is how do you prevent the fault, right? Or how do you detect? So you would have heard about, okay, people creating those health checks, heartbeat for your key APIs, or they would be running certain automated test cases, synthetic test cases at a frequent interval, right? It's not human who are running those common cases, but through automation, etc. So why we are doing that? It's because to detect in case of any issue, we get to know before the customer. So if you know one of the quality attribute is we cannot have our system down for more than say uh, 8 hours in entire year, then your observability has to be very strong, your alerting has to be very strong, right? So you would create a lot of dashboards using your observability tools like Dynatrace and others, your APM tools, etc. So wherein you'll be checking, okay, heartbeat of your key APIs, the error rate, like, okay, are the error rate consistent or are your error rate increasing? The moment your error rate is increasing, you want to be alerted. Now, alert could be in the form of email, it could be form of pager duty, right? Now you understand. So it's not just about managing the backlog. It's not just ensuring that team is delivering what they committed for the sprint goal. There are a lot of things you also have to drive. A lot of things even you have to suggest, right? Okay, team, we are nearing the live production date where we are going to roll out this feature. Okay, are we taking care of these aspects? Have we created health? Do we have both ready, which is going to monitor the performance of your system or API or user error, etc. How do we ensure that if the the response time, expected response time is 2 milliseconds. So have we added any alert wherein the moment the response time goes from 2 milliseconds to say 3 milliseconds, you are alerted, right? And so that you can take those call of, okay, do I need to scale? Do I need to add caching, etc.? So these are the questions you'll start asking your team if you know about the requirement. Okay. Availability, how do you get to know about the availability? Yes, it's like, okay, uptime, how much, like, okay, whenever we talk about availability, you'll hear from the developers or from your SREs that they talk in terms of 99, 99.9, 99.39, 4 nines, 5 nines. So those nines tell you for in a year for how many hours. If your system is down, it is still acceptable. But again, that doesn't mean that if you said that you are going to have 99.99 availability and still you are not going to monitor your system. You have to constantly monitor and ensure whatever uptime you thought about the system is there. Okay? Downtime. And in all these cases, important factor is, as I said, softwares, any software you would have seen, even Amazon, mm, outages on Amazon, outages on Flipkart, anywhere, right? Outages would happen, but you have to understand how do we resolve it. So one of the factors here, mean time to resolution. So I hope you all are able to follow that why the requirement forms your source of all these discussions, and why as scrum masters, delivery managers, etc., need to know this, right? Like if you didn't know, still you are able to do the work by talking to the concerned stakeholders. And again, you don't have to go into depth. It's just that knowing, if you know stuff, you'll be able to drive, you'll be able to fill those gaps very easily, right? So you have to evolve with time. Yeah. So I think this is it. In next session, now we'll start going into different aspects of our system design, right? So from requirement, you get to know your user flow, you get to know your data points. Now we'll study how these requirements help you in designing your APIs. Now, what are APIs? I'm sure by now you would have, you know, what are your APIs, etc. But we'll still talk about an API. What are APIs? And we'll also see that how from the requirement you're able to design your APIs, which is your programming interface. Okay, you would have heard about gRPC, you would have heard about REST. So all these are the protocols. Okay. And then GraphQL, these days you'll hear about GraphQL, BFF layer, etc. So we learn about all those things. But again, what would be the source? Like when we'll go for, say, REST, when we'll go for SOAP, or when we'll go for gRPC, everything would depend upon your requirement. So understanding the requirement is the first aspect, and then understanding the quality attributes, system constraints would be the second. From those, then we'll start building our system. Okay, how is API designed? Okay, once you've designed the APIs, okay, how do you achieve performance? How do you achieve scalability? So we'll talk about auto scaling, we'll talk about horizontal scaling, vertical scaling, etc. Then in that payment example, you saw that, okay, you placed an order has to be saved somewhere, right? So we'll talk about databases. So we'll talk about a lot of things. We'll start building from this session. So what is it that you have to do today? Just observe what's happening around you, or the application you've been supporting, or the team you've been supporting so far. Just go and read their documentation. Okay? So those applications, if they are already live and you're building upon it, just explore that application and then read the design, then read the requirement and see, okay, does this make sense? Or the blockers you would have helped remove, not blockers related to people or a process, but the technical blockers which you would have facilitated, right? So understand, okay, what were those blockers, how they were resolved. So from there also you'll get to learn a lot of things. So go ahead and observe what's happening around you. And we'll come back in our third episode where we'll start talking. Now we'll start going in detail, not the technical detail, but yes, we'll build upon these concepts. So thank you, and I hope you have a great day ahead.